Hi there and welcome to the section on reverb. Following on from the first video, I want to elaborate on the concept of reverb. This is something I've spoke about in more length in my other courses, but I'll do a quick overview to get you up to scratch. There are also tutorials on the Sonic Academy website dedicated solely to the subject, so if you want to know more after this video is over, I'd recommend going over there and checking them out. So I'm going to begin as if this is the first time that you've ever heard of reverb. Chances are you already know what it is, and some of you might even know how these functions and parameters here work, but I'll explain nonetheless. So reverb is the sonic signature in which sound will travel around a particular space. The echoes or sound produced in different environments will vary greatly depending on their context. So for example, picture the sound that you might hear if you were to shout inside a cathedral or a concert hall, as opposed to shouting inside a small bedroom or a tight space of some sort. And by just visualizing these two contrasting scenarios, you'll already start to get a feel for what reverb is exactly. Now in the digital world, we have to artificially recreate these different types of acoustic spaces, unless we've actually recorded in a large space with sufficient reverb. Reverb in the case of this clap sound will give it a more lively edge and help it sit better in the overall mix. So let's begin going through each of the parameters and demonstrating their functions. To do this, I'm going to solo the reverb insert, but to do this isn't as simple as muting the dry insert, because in FL Studio that will also mute the send, as you'll see. So what you have to do in this case is remove the routing between the clap and the master by de-clicking the arrow on the master when you've highlighted your relative insert. So now you'll hear just the clap's reverb signal on its own. And now let's start going through the parameters from left to right. So on the very left here we have a display giving you visual feedback on the type of space being simulated. We can click and drag this visual to change the respective size of the simulated space. And you can also use the designated size parameter in the middle. So if I turn it up to full, we'll be simulating a larger space, and if I turn it down to minimum, the resulting sound will be that of a smaller space. So here's it up full. About halfway. Next to that we have a mid-side function, which is a topic that probably isn't all that suitable for a beginner's course. Basically this determines whether the mid or side portions of the input signal will be affected. Mid is the summed left and right channels to mono, and side will alter how the sound is if it has stereo information. So this clap does contain some stereo information, so you'll hear a difference if I switch between these two modes. Now moving on, we have high and low cuts, which will remove the respective frequency ranges. Sometimes a reverb may sound either too sharp or too muddy, or usually a blend of both, and so by cutting certain frequencies within the reverb signal can help to shape it so that it sits better in the overall mix. You can also use an EQ after the reverb on the mixer inserts to have even more control over the frequency properties of it, such as making boosts and more precise cuts. So let's just change these parameters first of all to show you how it sounds. I'll bring the low cut up first. In the next section here we have pre-delay, which determines the time between the input and the first reverb reflection. So let me quickly route the clap back to the master so you can hear this in better context. I'll just turn the reverb send up a bit too. So here's the pre-delay. By default this value is measured in milliseconds, but if I activate the switch below the wheel, you will see that it switches to a tempo-based mode that is useful for keeping things well ordered instead of random values. Now smaller values are more suited to smaller room simulations, and conversely larger values will be more appropriate the larger the space you're trying to simulate. Now below that is the size parameter, which we've already looked at, so let's move on to the diffusion parameter down at the bottom here. First of all, I'm just going to show you how this affects the sound while simultaneously changing the size in different ways. So what diffusion is doing is altering the density of these reflections. So high values will create a dense sound of reflections being produced, whereas lower settings will make them sound more sparsely placed, and therefore more distinct to the ear. Moving on, we have the bass multiplier, which controls the decay of the bass frequencies within the reverb. I'll explain what decay means in just a second, but below this is crossover, and this is linked to the bass multiplier and controls the point of which bass frequencies will be boosted. Now let's look at the decay function up here, which is one of the more important parameters of reverb. This controls how long it takes the reverb to decay. Longer times are suited to larger room simulations, whereas shorter times are best suited to smaller situations. So let's move both the size and decay parameters accordingly to demonstrate. Since we're at a full size, I'll turn the decay up. And then back down. So as you can hear, the sound ranges from what seems like a huge open space to the other end of the spectrum where the sound has quite a tinny metallic quality to it. Since this decay parameter doesn't have a tempo lock like the pre-delay has, you may want to look into setting decay times manually. Using a website such as testtone.com, you can find out how different measures within certain tempo ranges are measured in milliseconds. So let me put up a screenshot from the website to show you what I mean. Now as you can see, this gives us the values for note fractions and single measures, and this can be a handy way of keeping the reverb tight in the mix. So for example, if you imagine a kick and clap pattern where the kick hits every beat and the clap hits in the 2s and 4s, using these values you can determine the time between these measures and set up the reverb so that it fully decays before the next hit arrives. This isn't always necessary and is a fairly subjective matter, but it can definitely help to keep things tidy. So moving on, below decay we have damping, which dampens the high frequency content of the reverb, or rather how quickly it decays. We've already looked at the wet and dry parameters, but in the middle of them is an early reflection slider, which sets the level of the first reflections in the reverb. And finally below that is a stereo separation wheel, which when turned left will give the reverb full stereo content, and when turned right sums the signal to mono. When it comes to prominent elements like the snare, I personally find moving the signal closer to mono is better in the overall mix, even if it doesn't sound great on its own. Of course, this depends on the track at hand, but stereo reverbs can occupy a lot of space, so just be mindful when applying them. So now that we understand what reverb is and how it basically works, let's look at integrating it into the drums and lead synth. So I'll see you in the next video for that.